Find the average rate of change of the function as x changes from a to b. Okay, we're looking at f of x equals 2 minus x squared, a is equal to 3, b equals 7. Okay, I'll write out the formula for average rate of change. Okay, which is f of a, or rather f of b, minus f of a all over b minus a. Okay, so if I look at f of 7 minus f of 3, okay, plug in 7, plug in 3. For 7 I get negative 47. For 3 I get negative 7. Okay, negative 47 plus 7 is negative 40 over 4, or I got negative 10. Okay, is that what you all got? Right. 2 minus 49 was negative 47. Okay, average rate of change. Not difficult, right? Just basically plugging in. Now, another concept related to this is the difference quotient. Still an average rate of change because we're still evaluating the function at 2 points. This could be our point A, and this could be point B, which happens to be a distance of h from A. Okay, again, this is one of those things we're looking at for calculus, and so once you get there, because I know you're going there, you'll need to know how to do that. So still doing just an average rate of change, just using some different notation. Okay, and the difference quotient is also different from the average rate of change because we usually do it a little more generally. We're looking for a function, not necessarily evaluating at 2 specific values. So we have some step-by-step instructions for helping us find the difference quotient. We're going to write out the definition of the difference quotient. We're going to plug in x plus h and x, and then we're going to simplify. Okay. So our difference quotient is f of x plus h minus f of x all over h. Okay, when I plug in, okay, we're plugging in x plus h right there. Okay, so we get 2 times x plus h plus 4. Okay, all of this is our f of x plus h. Okay, now I'm going to subtract from that f of x. So minus 2x plus 4. Okay. Okay, all over h. Okay, so we plugged it in. All right, everybody okay with how we plugged in? Because that's probably the trickiest part, making sure we plugged in correctly. And so now we simplify. We get 2x plus 2h plus 4 minus 2x minus 4 all over h. And so not right now. No. Yep, just in fact, let's just ignore that. I don't think we're going to use it at all. Okay? We have to go through this process, and I probably copied this from my calculus notes where we would have used that. But anyway, we're fine. Get rid of that as well. And notice here, I have a note that once we've simplified this, what's remaining should have a factor of h in it. so that we can cancel that from between the numerator and denominator. Okay, so we get 2h over h, or just 2. And so that's what our difference quotient is. It doesn't always come down to just a real number. Sometimes it'll be, variables and all involved as well. Okay, questions about that? Okay. My guess is that we have another example. All right, find and simplify the difference quotient. So we're going to do the same thing again. Okay, that's our definition of the difference quotient. So we're going to plug in, okay? Anywhere we see x, we have to plug in x plus h. So we get x plus h squared minus x plus h. Okay, all of that is our f of x plus h. Okay, minus, we plug in x into this thing, so minus x squared minus x all over h. Okay, that's how we plug in. Okay, then of course we've got to expand this thing. So we get x squared plus 2xh plus h squared minus x minus h minus x squared plus x all over h. Okay.
So when it's the f of x plus h, we just, whatever f of x is, the first variable, like x squared, we would just x plus h and then square it, and then whatever, just keep going there.
That's right. Wherever the x is, we plug in x plus h.
Okay.
Okay. And so I cancel where I can. Okay, and notice that everything that's left has a factor of what? H. Okay, we want that. All right, and so we'll go ahead and I'm going to factor the h's out since I'm running out of space. Okay, when I factored out h, I was left with 2x plus h minus 1. And then, of course, these h's between the numerator and denominator cancel. And so we are left with 2x plus h minus 1. Questions about that? All right, very good.